Self-aligning rotational latching mechanisms, a framework extension for orientations and fast latching. In our previous work, we introduced LIMMS, Latching Intelligent Modular Mobility System, to help with last-mile delivery. With 2 limbs, it can attach itself to the side of a truck and act like arms to move a box. With 4 of them, they can attach to a box and act like a quadruped to walk itself to the door and return in segue mode. Here we have a simple demonstration of the latching mechanism. As it begins to rotate, due to its geometric constraints, the latch will self-align despite having such a large offset to begin with. In other previous work, we showed the probability distributions of 2 blades versus 3 blades, where yellow is 100% successfully latching and dark blue is 0%. As you can see, the 2-blade design outperforms the 3 blades by far. In this paper, we extend the framework to work with orientation misalignments by using either side of the blade profile shown in red or blue. To keep the large areas of probability for successfully latching from our previous work, we maintain the optimal parameter constraints including the 2-row distance between the blade tips. We extend this 2-row relationship to the opposing blade profiles as shown in blue. Here we show a 2D side view of the latch in blue, contacting a latching pattern or box in brown. As the brown plane varies, it can only be oriented relative to its base. Using omega and h, we can define a theoretical limit for any design. This is how latching performs without any misalignment. Position and orientation tests were conducted as well. In our final test, we tried to switch the base of the robot. The robot has no cameras for workspace feedback. It is following a trajectory, but given the task, it experiences approximately a 4 cm positional misalignment. The orientation misalignment is harder to determine, but it is present. You can also see the mechanism quickly correct itself. From the moment it touches the hole pattern, it takes only 0.149 seconds to fully align, which is the fastest rotational latching mechanism that the authors are aware of. Here we can watch the same experiment from the back view. We can clearly see a single blade enter and the mechanism pop itself back into place. Let's take a look. We would also like to thank LG for sponsoring this research.